in the last 4 years with ConcealFab focusing on this whole issue of external PIM, which is something that's kind of a mystery to a lot of folks, and that's why we are going to have a discussion about this whole thing of PIM hygiene. Why is it needed, and how to perform it? And I guess what's on your mind about this?
The operators used to require PIM testing, but then all of a sudden they stopped. Can you let us know what's changed?
That's a good thing. And so if they've stopped, why are they saying the word PIM again? So in the beginning of time, we used to worry about PIM inside of the structure, from the antenna to the radio, and that's because there was a lot of things going on inside of that antenna. The antenna was the worst source of PIM, passive intermodulation. That is when two or more signals mix inside of a surface, and those signals vibrate that surface, and that surface vibrates at a frequency that the cell site can hear. And if that is louder than what your cell phone is talking back to it with, well, then the cell site becomes deaf. And that's a problem. They were testing this because, you used to make cables in the field. You used to, the quality control from antennas wasn't that good. But a lot of that stuff had changed. And a few years ago, the carriers all said, hey, don't worry about testing it anymore. We're good because we trust the manufacturer. And I'm sure none of you on the call today have ever pulled out a bad cable or a jumper from the manufacturer, right? Well, anyway. After all of that stuff went away, then FirstNet happened, and there was this big problem with not the cables and antennas, but all the stuff around a site. And that's why we talk about PIM hygiene. It's the elimination of known PIM sources near a base station antenna. Because what we found over the last, about 3 years ago, we've always known about a thing called a reactive near field. There's a big long calculation you can do to find that. But what it really is this ugly donut of energy around an antenna. And the taller the antenna, the bigger the donut. So if you have a 4-foot antenna, that donut is around. Whereas a 8-foot antenna, that donut at 600 megahertz can be 11 feet around. So it's a big area that's lighting up things near an antenna. And you can actually, you can hunt and find all these things. It takes days and nobody wants to pay for that. Or you can just use your eyes and get rid of it. And that's what we're going to talk about, is whether we have to remove, repair, or replace PIM sources. Does it work? Well, sites that are really bad can literally be deaf. I mean, just no traffic is going through them. So big bang for the buck doing PIM hygiene there. But in order to get the improvement of 5G, all of that stuff that they keep on talking about, high bandwidth downloads and uploads and everything, you need to have a really clean site. So even getting a site like this one was not performing well. It was at neg 106 on the RSSI scale, but it still wasn't performing as good as it could. And so by doing just simple hygiene, the stuff we're going to show you today, we got significant improvement, and that improved the performance of the cell site. So all the carriers want to have bragging rights of, we've got the best, T-Mobile's saying we've got the largest, we have the most, but do they have the best? Well, having really a good performance, a good experience on 5G is the key. And why has Verizon gone in big time? Obviously, AT&T, we know they had problems with FirstNet, but Verizon's gone in big time because C-band's going to get turned on. And so the same math that created all those problems for FirstNet are going to create the same problems in C-band. And most of us know that, or if you don't, you're finding out that C-band is going to get turned on in January, but not all of it, just the first 60 to 80 megahertz. And what affects the first 80 megahertz of C-band the most? Well, a combination of PCS and cellular frequencies, 850 and 1900. Those two slam into C-band with the loudest PIM. And it's not the new C-band radio. It's not the new C-band cables. It's the existing 850 and 1900 that are sitting up there. They're ringing like crazy right now, but nothing's listening at this frequency. And as soon as they turn that frequency on and start that radio listening, it's going to hear all of this noise that's been generating for years. But it just, they didn't notice it because they weren't listening there. And that's the whole key. It's, why perform hygiene now? Why didn't we do it before? Well, nobody was listening where all this PIM was being generated. Now they're going to be listening there. You got to perform the PIM hygiene.
So can these problems all be fixed?
Well, most of them. What we have seen is that we're getting 25% of the sites are fixed 100% by doing what we're going to be talking about. When we dug down into the numbers even deeper, we find that 10% of the crews are having an 85% success rate. So if it's done right, that number goes up to 85%. So yeah, big bang for the buck with doing what we're doing. So what are we going to talk about? Well, I'm going to say that most PIM is either because something is loose or because there's some sort of corrosion. There's a thing called galvanic corrosion. Now, I've heard this kind of funny. I've heard people say, well, when you take a stainless steel hose clamp off and you see all that white powder, that shows you that steel hose clamp was not on tight enough, and so it was rubbing off the galvanic stuff, the galvanizing from the metal. Not true, not at all. That was totally on there in fact, it has to be on there very tight to get this stuff. What this stuff is, as soon as stainless steel touches galvanized metal, you've actually created a battery, and galvanic corrosion starts immediately. You don't notice it day one, but a year or so from now, all this stuff are little crystals that have grown because of those two metals being far apart in the galvanic table. So those are literally metal crystals that have grown between those parts, and so tightening it more doesn't make it better. You just have to get rid of it. So that's the key. How do we fix stuff? Well, we either eliminate galvanic mismatches. We make sure that things are tightened correctly, because loose metal is also a huge problem. If I can't do either of those two, well, then is there a way to make sure that metal's not touching? Insulating it with something, some sort of plastic perhaps. And the last thing is just making sure the RF doesn't get there, some sort of blocker. So these are the tools that we have available to us to fix problems. We provide all of these solutions. PIM-free cable supports which are approved by all carriers, including Dish now, by the way. So all 4 carriers have approved and are encouraging the use of our products. RF barrier solutions, and then we have test and measurement solutions, because that last 15%, sometimes you have to go hunt it and find it. And there's a separate class that we perform on that, teaching you how to find getting rid of that last 15%. So how this is going to go is, I wish we could do this a little more interactively, but it's a little one way. I'm going to show you a picture of a problem. And this is based on the last 4 years and thousands of sites that we've been on. I'm going to show you a picture of a problem. We're going to talk about whether it's loose or galvanic, and then which one of these things is going to fix that solution. So with that being said, what's the problem here? Well, yeah, it's loose. No kidding. That jam nut was put on, and somebody wasn't that bad that they left it that loose. It's that this thing was not torqued correctly on to lock into that jam, and so maybe it was spun on together at the same time. This is what happens when that cell site vibrates in the wind, plain old earth vibration. That thing backs off, and that becomes a big source of PIM. So obviously tighten it. Here's an interesting one. This happens all the time. Things kind of get jammed together here. This actually is not the problem. The problem is right here with those threads being loose, and it's giving us a situation where we can't really. So it helps us. This really should have been cut off. So the solution is repair it. Cut that thread back to here so it's not going through that hole. Another problem here, what's happening? Well, again, I have something loose. It wasn't intended to be loose, but this mount just kind of, yeah, it was easy to install this mount by just resting it on this other angle member, but it's created a situation where I have this whole side in here that's loosely contacting. And so again, the solution is repair it, move this bracket up a little bit so that I'm not touching the other piece of metal at all. It's a great bracket, nothing wrong with here. I have no dissimilar metals, so it's just moving that up to a position where it's not touching. Here's another thing happens all the time out in cell sites. Again, I've got a loose contact. Now, you wouldn't say it's loose, but that pipe just barely touching right here. And again, hey, I've built cell sites. I've done this exact same thing. I rest this pipe down on that L bracket. Simplest way to fix this thing is to just raise that up just a little bit. Doesn't have to be raised up much, but it can't be touching this L bracket. Here's an interesting one. And so from the other two slides, you look at this and you go, well, that's loose. And yeah, maybe it is, but maybe it's not. Is that worth repairing? Here's the thing where I would, because to repair that would be a pain in the butt. I've got to loosen this whole thing, put some sort of insulator in there. But frankly, if I have enough mechanical contact here, that's probably not a problem. I would probably go ahead, fix all the other problems on the site and see if that's a problem. I would not actually go. So again, PIM Hygiene is also bang for the buck stuff. Some things, if it's going to take me 3 hours to fix this problem and I can fix 200 other problems in that same 3 hours, go fix those 200 others. Wow, downtilt brackets. Yeah, loose. Yeah, the older generation of downtilt brackets had a lot of problems. It has this huge scissor area here that create, I can't torque anything down on that. I can torque that and this, but this area could still be loose, and we found some brackets are worse than others. So you replace it if there's an OEM solution available. Sometimes you just have to repair it by putting some sort of insulator in there. The other thing, if the carrier wants it, I mean, how many times have you actually used a mechanical down tilt, right? These things are all set up at 0. So if your cell site is squared up, then, again, if directed by the carrier, remove this down tilt bracket and just connect this piece to here and you're good to go. So, seek direction from your market there. Anyone see a problem here? Has anyone ever left spare parts on a cell site because, well, hey, maybe I'll use them later. I'm going to be a nice guy and leave that stuff there. Or, hey, I'm just not getting paid to take all this stuff off. Well, that's kind of changing. Carriers are saying get rid of this stuff. So yeah, simply remove spare parts. This happens on rooftop sites all the time. You fix stuff, but things drop and things fall down, and yeah, if all that stuff is in the main beam of the antenna, well, yeah, it's going to cause PIM, and that's where a roof can be lighting up PIM in front of an antenna. So you got to just remove it. Construction magnets are really good things to have with you. That's what they use to clean up nails on a site after you frame it in a house. It can help you get rid of all this stuff too. Well, somebody cut some metal at some point in time, and now I've got a bunch of loose stuff there. Yeah, it's just being clean, having a brush handy when you do cuts. I mean, we've all done it. I know it happens. This was probably because they were cutting these threaded rods shorter there. But instead of just blowing those away or brushing them away, they just left them there, and a year later those things become a source of PIM. Okay, when we first started to do all this PIM training for AT&T, the original thought was we were going to go out there and hunt PIM and find the PIM and then fix the PIM, and it became obvious real early on that every single one of these snap-ins was a source of PIM noise. And so what do we do about it? Well, you replace them. New products are on. We're created for this market. We've created a hybrid metal snap-in instead of just an all plastic. It's been out there for a long time. And what's nice, I feel good about saying this. These snap-ins, I used to say, well, you know, testing says that it should last for X number of years, but now I can say with a lot of confidence, yeah, this part has been on towers in New Mexico and Arizona, and it's also been on towers in North Dakota for 3 years, and they're still there. So yeah, they work, they get rid of PIM, and they're very strong because of how we made them. So hose clamps, we already talked about this a little bit. I've got loose and galvanic happening here. You see, a lot of people remember something that we teach in the class, PIM does not happen in the air. It's when metal's barely touching metal. So a lot of people will look at that and say, oh, I'm probably going to get PIM from that. No, it's not that. But when you take that thing and you tuck it into the slot to help the site out, well, you just created more loose contacts there. So, you know, the solution to this thing, get rid of them. There's no way to eliminate the loose problem or the eventual galvanic problem. And so, you know, get rid of them, replacing them with good acetyl straps. Here's an interesting one. I've got a radio or I've got a TMA on a tower, and this is what was supplied by the part manufacturer, and they're saying I have to install it with this part. So what do I do? Well, some of these manufacturers are saying, yes, you can, yes, with the proper acetyl strap, and the ones that we sell, we've had them made, they're twice as strong as the other acetyl straps on the market. And a pair of acetyl straps is as strong as one stainless steel hose clamp. So some of the guys, especially TMA guys, are saying, yes, you can use the acetyl to replace the stainless steel. Otherwise, if it's a radio or something like that, you can't. The white no-ox is a good thing. You basically loosen this up, brush off the existing galvanic corrosion, that white dust I talked about before, spread on this silver no-ox and retighten it. That is a lot more time consuming and it's expensive, but it's the required solution. Stainless steel standoff adapters. Well, we know, again, we've got a couple of problems here, right? I've got the galvanic corrosion from the steel versus the galvanized metal. So I should just remove them. But, you know, I just want to point out I have another problem here. And I see this on sites all the time where I have this stack of stuff and I've installed the first one, and the easiest way to install this one is to just rest it on the existing standoff and tighten it, and I rest this one on this one and tighten it. Well, the problem with that is I've got metal barely touching metal where all these things are touching. So that's not a good solution. Obviously, getting the stainless steel off of there solves both problems. Angle adapters. Yeah, a lot of us bought stainless steel angle adapters because we were told to. Now, there are all galvanized metal angle adapters, so that would be a good solution. Except that little screw can gouge into the metal and you could be creating a future PIM problem. So, you know, replacing them with all plastic solutions is really the way to go. Mix and match. Here I've got all galvanized steel and all of this stuff is stainless steel. Again, galvanic corrosion, all this stuff is a problem. So another thing inside of here, and actually I should put that, note to self, I've got spring nuts in here, and those spring nuts cause a loose problem. So, you know, even if I have all galvanized, I want to remove those springs, so ripping them out with needle nose pliers is a good solution. But the ideal solution is to just make sure if I've got galvanized here, then make sure I've got galvanized here. It's just the right thing to do. Same thing with OEM hardware. I've got galvanized steel and stainless steel. Sometimes you can replace this stuff if the OEM approves it. They have, a lot of the OEMs have been coming out and saying, oops, we made a mistake, and they have replacement parts for this stuff. So sometimes that's the solution. If they don't, I wouldn't do anything with this. This is something where you just wait and see. At the end of the day, this is probably not the loudest source of PIM on the site. So while it can be a problem, it's probably not the loudest problem. Again, we've got some more stainless steel OEM brackets, and yeah, the answer is the same. I can perhaps, this is stainless steel touching here, and that's where the problem is, that can get pretty loud, especially at that position in the antenna. What I could possibly do is, again, use that NOx as an insulator, so that can work. Aluminum brackets seems like a problem. Well, it isn't. Aluminum and galvanized steel are actually very close to each other in the galvanic series, so that's probably not going to be a problem. And it's kind of right in the middle. So if I have a stainless steel screw going into aluminum, again, probably not going to be a problem. They have to take a long time before that's a problem. So this is very rarely an issue on cell sites. Okay, somebody replaced the steel standoff with a strap. Problem is, they strapped the ground cable directly to the galvanized pipe. They've created a loose situation here. Also, it's a galvanic corrosion problem because copper and galvanized steel, again, pretty far apart. So got two problems here. You really need to mount these correctly. Put a little standoff in there, all plastic, and snap it in. Works well, and make sure that this ground never actually touches that pipe. That's the important thing. Rooftop sites, you see RF safety signs all over the place. Now this is aluminum, this is galvanized, and what I tell you, is that a problem? Probably not, but I got baling wire holding it on, and yeah, that is a problem. So, finding a different way to mount that thing. We have a nice little kit that can be used to mount it. You just drill or pop a 3/8 hole into the sign and just mount it on there with the seal strap. Rust never sleeps. And yes, well, actually with this site, my goodness, I can't tell you how many problems I've got here. I've got rust, so I got to remove it with a wire brush and then apply some sort of cold galv to it. But obviously at the same time, I'm going to get rid of all these mismatches and this ground wire just strapped into there. So I'm going to replace all this with acetyl parts and make sure that ground cable is part of this little standoff solution instead of strapping directly to the pipe. When I first trained this class a while ago, I got a call literally the very first week from a crew saying, hey, I got the tops and bottoms of these pipes is causing a problem. What could that be? And we took a look at them, and theirs didn't happen to be rusty because it was they had spray galv, but they did not file this. So all of these metal burrs in here was actually lighting up the site. So getting rid of those metal burrs. If I have rust, obviously get rid of that, and then spray galv. That's the key there. I talked about this a little before, coming back to it, the spring nuts. Yeah, it creates a loose metal to metal contact. It's a nice thing for setting that back nut in the strut, but once you're done with it, get rid of it. And needle nose pliers are great. Just reach in and pull that thing out. You just use a little twist motion, and it gets rid of your problem. Also, inconsistent pipe connections. I have a mixed match of all sorts of stuff here. So, basically repairing and getting rid of the Here's something that you may or may not be able to do anything about. You have your crow's nest, and you have the metal grating up there. If they're loose, these things can get loose up there. If you're walking around and you hear stuff, you hear it shifting, tighten these things down, make sure. But some of these we actually had to go back and replace with fiberglass because it was just such a field of PIM between eventual rust and loose metal. The only real solution. The other odd things that we find at cell sites, little chains just left on, baling wire left on. Who knows what that clip was used for at some point in time. Basically, if you can get rid of any type of strapping and clips, this is actually metal strapping holding on. I think this goes to an RF safety ring that goes around this rooftop site. Getting rid of all that stuff, paying attention. You know, I've seen a lot of crews go out there and they replace the snap-ins and they think they're done with their job and they're missing all of these things that we see on a cell site. This is kind of a neat way to make sure everything stayed nice and straight. Just put 5 or 6 washers in there. That was kind of unique. Have no idea why that wire ever existed. And you know, we've got this other, this is an interesting one. They actually should have put this threaded rod. There's another place to put it out here. I guess the crew thought they were doing a good job by putting it close to the pipe, but it wasn't actually the right thing to do. It needs to be out here so that thread rod doesn't touch the pipe. And yeah, we have other problems too that we see. This is examples of poor hygiene. Sites that they started to do it, they kind of half did it. Okay, they were told to remove the hose clamps, but they didn't think that this was also stainless steel. You know, it should be replaced with a nice little Delrin solution that we have. And yes, it is approved. You do not need to have steel touching this. This is not part of the grounding assembly. I have this as an insulator, so make sure that this is not actually coming in contact with that. So putting another piece of plastic in there works just fine. Here's another case of, okay, yeah, removed all the metal snap-ins, but kept all, strapped it. And by the way, these are just Home Depot straps. They say UV resistant. There is no UV stability spec on them. They are not approved by any carrier. But so that's wrong in itself, but also, you know, making sure that you get rid of the steel that it's strapped into. So half doing a job is like not showing up at all. This slide just hurts me. The crew went out there, they replaced all the snap-ins with our snap-ins, and then I get a call saying, well, your parts don't work. Well, yeah, they do, but you got to get rid of all of the problems, the stainless steel, all these standoffs. It all needs to be done, or it's like you didn't show up to the site. So, you know, just replacing the snap-ins and leaving all the mounts is not accomplishing anything. All right, so quiz for you guys. Think about this. How many do you see on here? Give you a second. How many things? 4, 5, 7? Well, let's count them up. I've got loose metal to metal contact with the snap-ins, galvanic mismatch here with snap-ins. I've got some more galvanic mismatch with this angle snap-in adapter going into stainless steel. What else do I have here? Yeah, more galvanic mismatch and more galvanic mismatch. Oh yeah, look at that. It's more stainless steel hardware coming into this thing. So yeah, that was a total of 6. I didn't count each individual snap-in. So how many PIM problems do you see here? Go ahead and think about it for a second. How many you guess? Yeah, I wish I could give you a prize if you win, but I can't do that. But so let's count them all up. Yeah, somebody decided to leave some spare parts just in case somebody needed it in the future, I guess. I don't know. Yeah, you know, somebody could use that hose clamp in the future someday. I don't know. We'll just leave that on the site. Yeah, metal snap-ins. So that's correct. Galvanic mismatches again here. Stainless steel going into galv and galv going into stainless steel and back and forth. So yeah, issues with that. And here's another interesting thing. This is galvanic this is galvanized steel, but I have a stainless steel set screw. That just make sure you buy the parts that are all galvanized. And then this is interesting, and this is why it's just good to get rid of these in its entirety. I get this edge touching right in there, and that becomes a PIM problem in the future. Oh yeah, see that pipe touching the bottom there? Remember we said you got to raise that pipe up just a little bit. So this one had a total of 8. So lots and lots of problems on here. So I went through that kind of fast. And that's why I think they're recording this, so you'll be able to review it later and send it off to your colleagues. But you know, PIM Hygiene helps improve network performance. There's no question about that. And it's not just the guys now. Like I said, Dish just is proved us they're not technically going to have any problems, but when they turn on C-band, they will. So everybody's waking up to, yes, this is something that we've got to get rid of. So we got to use common sense, eliminate anything that's loose, get rid of the galvanic mismatches. It's up to you guys to apply this knowledge. It's only as good as how much PIM gets. And PIM, by the way, just to refresh, if you know this, if you don't, this may be new to you. It's not like, okay, I have 5 things of PIM, so it's this loud, and I have 10 things of PIM, and now it's even louder. And that's not how PIM works. I could have one really loud thing on the site. I could remove 100 others, and if I hadn't removed the loud thing, it's like I didn't even show up. So you've got to be careful what you do. Like that, those guys that replaced all the snap-ins left all the things that the snap-ins were connected into. It's like they didn't even show up. They didn't actually solve the loudest problem. We also have a hands-on course. It has a little more depth than this, and it also gives you a hands-on version. This actually has 24 PIM problems in it. And the cool thing is, every time I've brought this out to a class, the exact same things that I see that gets missed all the time on a cell site, they missed when they're looking at this this kit. So it's realistic. Really, some people are good reading a book. Some people learn by seeing a presentation like this, but a lot of people really need that hands-on, and this gives you that. We're going to be touring all the local branches of Tally with this hands-on course in the near future. So look forward to that. Looking forward to meeting some of you guys in person and doing this. And thank you, Tally, for allowing us to be able to present this.
Thank you, John. I haven't gotten any questions yet. Does anybody have any questions?
So I either put them to sleep or I actually.
I don't think you put them. I don't think you put them to sleep. But no questions came in, so I guess we'll just wrap this up. I'd like to thank John and ConcealFab for today's webinar. I'd like to remind everyone to visit tally.com for all of your ConcealFab product and solutions. I thank you very much, and everyone enjoy the rest of your day.